Welcome to the Bootloader. I'm Todd Kurt.
And I'm Paul Cutler. Todd and I each have 3 things to share with you, and we'll spend 5 minutes, but no more, on each one. Todd, why don't you get us started?
Sure. This week, I'd like to start out with talking about the 10-cent, $0.1 Arduino chip that's based on RISC-V. So, a little bit of backstory here. One of the things that made the Arduino platform really useful and popular back in the early 2000s were 2 things. One, well, 3 things if you count the huge community and effort. But the hardware specific things is the fact that it was based off the Atmel ATmega 168, which was only $4, and it contained all these features. It contained 16 kilobytes of flash, 2K of RAM. It was a RISC architecture. It had a bunch of useful peripherals like serial ports and I2C ports. And then separately, there was an open source compiler called AVR-GCC that you could use to code it. And on top of that was built Arduino. And it kind of took the world by storm because the closest competitor at the time was the $50 basic stamp. And so if you wanted an easy to use microcontroller platform, it really became obvious that Arduino was the solution. And so, and thus, now 20 years later, almost, everything has kind of an Arduino version or mode or whatever. And so recently the company WCH, which is the maker of the CH340 USB to serial chip that you might have seen on some of these dev boards that are out there, they've been getting into making CPUs. And they just announced that there is a 10-cent chip that is based on the RISC-V architecture, and it's basically an Arduino class processor. It's got 2K RAM, 16 kilobytes of flash, 18 I/O, 8 analog inputs. It's called the CH32V003. I first heard about this from our fellow hacker Akiba on Twitter, who was quote tweeting a guy named Patrick Yang, who works at WCH. And really, one of the other interesting things about this is that it's based on RISC-V, which is an open source architecture for chips. So before, like all of our chips nowadays that we use, like from the chips in our cell phones to the chips in our Raspberry Pi Picos, are all based on ARM cores. And it's a really good popular core that can scale from really big, powerful things like tablets and phones down to like little embedded processors. But for every chip, you have to pay a license fee to ARM. Like the chip company pays us, like you don't when you buy the chip. But the cool thing about RISC-V is that it's open source. So you just get the core and you kind of configure it for the scale of project you want, and then you embed it in your custom silicon, and you add the other parts of it you want, like the memory or the peripherals and stuff, which could also be open source perhaps, and then you make a new chip. And that's what they've done. And so this is sort of an open source design chip. I think they've not actually released the design because the particular licensing of RISC-V doesn't require that. But it does mean that the chips themselves can be a lot cheaper because there's not this license fee that's on top of it. And so I'm really excited. This just came out, and so they're only available on in sample quantities from LSCS, the sort of DigiKey in China. And so it should be pretty interesting to see how that goes forward. There's a big brother of this chip called the CH32V307 that has built-in USB, and there's a MicroPython port for that. There's Rust bindings for it. There might be an Arduino version coming for it as well. And so I think this will be a really cool set of chips to observe over the next coming years, because it could be like the next big thing. It was like it could drive down the cost of little projects even more.
Yeah, there's no question about it. I mean, RISC-V, I believe, is under the Linux Foundation umbrella, and they're a great steward of open source projects, whether it's hardware or software. And it's fun to watch that open source ethos start to infiltrate hardware.
Yeah, it's kind of crazy because a lot of these, when you're designing these chips, it's actually kind of a software problem. People often write these things in these languages called Verilog or VHDL, which is a description language for how you connect little hardware bits together. So you don't draw schematics for the insides of a chip. You can, but you often are laying them out either sort of with Illustrator to lay out the actual geometry of the transistors, or you're using this coding language that's very strange because it mirrors real life where everything happens at once. It's not like a normal coding language where things kind of happen in a line. So yeah, I'm really curious to see how this goes forward. I'm hoping to get some samples soon, but I think it might be a couple of weeks to a month before I get any.
Well, you got to take the slow boat over. So
that's right. So what do you got for us this week?
Well, let me ask you this: which code editor do you use?
Well, it depends. For most of my coding in C and Arduino, things like that, I use Emacs. I've been using Emacs since I was a little Toddbot. And for Node.js programming, which I do a lot of, I use VS Code or Atom. I haven't quite made the full transition yet to VS Code. For editing Linux config files, I use VI because I want to be exactly certain exactly what characters are being changed. So yeah, it's kind of all over the map. It kind of depends. How about yourself?
I just switched to JetBrains Fleet, which just came out last week. And I know that, as you mentioned, your code editor is a very personal choice, and I'm shocked to hear that you use VI and Emacs, but good for you. But I've been using PyCharm. I used PyCharm for about 3-4 years, switched to VS Code for a year, and then switched back to PyCharm earlier this year. And then when JetBrains, who makes PyCharm, as well as a number of different integrated development environments, IDEs, they have an IDE for every programming language out there. But they came out with Fleet last week, and it's in public preview. And it's free to use right now while it's in preview. And it looks like there'll be a free version and a paid version with a slightly different feature set, which is similar to what they do with PyCharm. But this one has a focus on speed. Fast and lightweight is how they describe it. So when you first open it up, it's a code editor, but there's a button in the upper right-hand corner called Smart Mode that enables IDE features, including code completion, quick fixes, and more, stuff like that. So if you want it really light and fast, don't click the Smart button. If you do want to get some of that code completion, those IDE-like features, hit it. Now, the other thing that's really neat is it has a collaboration mode. You just hit one button to start a session. It copies the URL, and you send that to your friend or your coworker. They click it. It opens Fleet, and it opens the project that you're working on. I tried it on my Windows box and my Mac OS box just to see how that collaboration worked, and it was really one click easy. And all of a sudden, I'm looking at my code from a different computer. So if you're doing remote coding or pair programming, it's really, really cool. One of the other things it can do, similar to VS Code, is it can be distributed. So you can connect via SSH to another box where it will install a version of Fleet, and you can actually use remote computing power to run your IDE remotely. Or you can connect to Docker or JetBrains Space service. I've been using it. I like it. It feels snappy. I don't know if it's just in my head, but it does feel quick. And I'm a hobbyist programmer, I probably only use a small percentage of an IDE's features. I'm not using the profiler and that kind of stuff, which is one reason why I like Fleet is I've got a pared down feature set, but it's still more than just a code editor might give me. Now, I'm going to call this what this is, and I don't know if JetBrains will appreciate this or not, but JetBrains is competing with VS Code. It looks like VS Code, where VS Code has icons on the left-hand bar. This has a couple on the top instead, but the look and feel was very reminiscent of it, and I think that's great. I think competition is good. It's going to drive innovation. And the other thing is, if you're looking for a new editor, GitHub announced back in June that they were sunsetting Atom, and come December it'll reach end of life. Here's another option for someone to try if they're currently an Atom user and want something that's still light and fast, and maybe don't want to move to VS Code for whatever reason.
Yeah, there's the whole similarity of editors or of these IDE style editors. For me, started way back in with Sublime Text, which I don't even know how long that is old, like 15 years ago. But it had a very similar thing, sort of a 3-pane where the right side is sort of a top down, like 10,000 foot view of your file, and the left is sort of your file hierarchy, and the middle is your code window, and it does a bunch of really good hinting of coloring and block completion if you're using a language that has curly braces and stuff. And Atom totally stole so much of that, and VS Code stole so much of what both Atom and Sublime are doing. And so it seems like, it's oh, if it works, let's just use it. and for me, that's great. The problem I always have with a lot of these big editors, like all these, is I came from a world where you are typing around in the terminal and you CD into a directory, and oh, there's a file, so you just type your editor space name of file and you edit the file real quick, and then you get out. And that's just not the way you use these big programs, where like if you just want to just open up one file and edit it and close it again, that's just not how it works. They take like, tens of seconds to start up, and they're meant to kind of just be this persistent thing that kind of lives on your computer.
Right. They're really focused on those big projects, just like you said, not that one file. And this is trying to find that middle ground, I think.
Yeah. Just the fact that it's got these sort of two modes of the quick mode and the smart mode is very interesting. So I'd like to see how that turns out after a while.
What do you have for us next?
All right, so so almost all my things are pretty much all very much low, small hardware things. So in continuing on small hardware, there's a thing called Person Sensor by Useful Sensors. Useful Sensors is a small company created by Pete Warden, who was one of the developers of TensorFlow, Google's open source machine learning platform. He's also a big believer in the TinyML movement, which is moving a lot of the machine learning stuff down to the devices to be as close to you on hardware that you control, rather than in some mysterious cloud system somewhere that you have no real input into. And so one of Useful Sensors' first pieces of hardware is this little tiny board that's about as big as a stamp called the Person Sensor. And it detects faces. It does basic facial recognition. It can determine if you're looking at it, and it's $10. And you can buy it right now from SparkFun. You talk to it via I2C. It's got a really easy API. It can remember up to 8 people. The people don't have any identification associated with them. It just like numbers the person 0 through 7. And so once when you put it into sort of a config mode, it starts to remember different people. And then later, if person number 3 comes back up, you can go, oh, person 3 has arrived, and they're looking at the device. And it's got StemmaQT quick connectors on it. So Pete Warden's example that he has an article on Hackster.io with a video. He's actually using an Adafruit Trinky with a tiny quick cable going to the Person Sensor, and it's this whole thing that's like the size of a stamp. And what he does is he uses it to look at him while he's at his computer, and if he looks away from his computer for long enough, it auto locks the screen.
That's awesome.
So and it's got a little LED on it, so it'll tell you, oh, I've detected a person, and so you can quickly see it's like, oh, it's a little LED on, and it's recognizing me. And then as soon as you look away, if you've got like your phone recording it, because you can't look back at it, if you get your phone recording it, you can see that the LED goes out and then the screen locks. And it's just amazing that we're doing facial recognition on a little $10 board, which means the parts cost is probably on the order of like $3, maybe even less. And you can buy them now. And so I've got a couple showing up, I think maybe tomorrow, but I can't wait to try this out. There's APIs in Arduino, RP2040C, Python, and CircuitPython. Like one of the other examples I saw was running off of a Raspberry Pi, where they just hooked it up to the I2C ports on the Raspberry Pi and then used normal desktop Python to control it. There's a pretty good developer guide, but the API is so simple that you don't really need a lot of big documentation to understand how it works, because it's a very small, simple device. Basically, just ask it, is there a person? And it says, yes, person 3, and they're at position X, Y, and my confidence in that it's person 3 is like 50%. So I'm very excited for this. It's pretty interesting, and it's hardware that you fully control. It's not sending data up to the net somewhere.
Well, that's the first thing I thought of, is what is the impact for becoming a surveillance society, right? We're being monitored all the time, and now here's a really cheap tool. What are people going to build with it? I want to believe that people are going to build good things, but you never know. But to your point, not being cloud connected is a huge bonus.
Yeah, totally. Like one of the things that I really like about this is that because like one of the nice things about TinyML is that the problem space is small, because the things have to be on a handheld device. And so it can't do a bunch of, global recognition of a person. It can just kind of tell, is there a human shaped thing looking at me. Like, in the case of, say, a coffee maker, where you've got two people who want different kinds of coffee, and then a person walks up and just presses the give me coffee button, it'll automatically create the right coffee for you. Or you can maybe, look at the wall switch and say, turn off that light. And you've got the cheap audio recognition thing somewhere, and it just knows that, like, okay, a person is looking at that light, and so I'm going to turn off that light. And so I think there's a lot of really cool applications that it just requires sort of the concept of a person looking at a thing rather than knowing that it's, Paul Cutler, living at this address with this phone number. All right. So how about you? What you got for number 2?
GitHub is in the news, and not necessarily for a great reason. But this past August, they launched Copilot, and they call it your AI pair programmer. So it's, using OpenAI's codex, and we just talked about OpenAI last episode with Whisper, but they've fed it all these open source repositories, and now when you're coding, it can make suggestions, not just line completion, but huge blocks of code. Mm-hmm. Well, some folks aren't really happy with that, and I don't think I blame them. Matthew Butterick is a writer, designer, and a programmer who's been using open source for 25 years, and he's also a lawyer. So if you go to GitHub copilotinvestigation.com, he lays out the case for why he thinks Copilot is problematic. So he's looking for people to talk to along with the Joseph Saveri law firm, because it's a potential lawsuit. No one's brought a suit yet, but I think Jamie Zawinski, aka JWZ, a co-founder of Netscape and Mozilla, also blogged this week that he's looking at a possible lawsuit as well. So I don't know if they're together or separate, but there's people out there that are really concerned. And what's really neat is Mr. Butterick shares examples of the problems, and it comes down to 2 things. One, how did Microsoft and GitHub train it? And then how is it used? So he asks some great questions. He makes some points that Microsoft probably could have done this a different way. Instead of sucking up all these open source repositories, it could have been opt-in. They could have paid some of those developers. Well, Microsoft claims it's fair use. Well, if these are all open source and they all have license, and the majority of licenses, almost every single license requires attribution. Even some of the most free and open licenses out there. Well, there's no attribution with Copilot. Even when it's pasting large chunks of code, you don't necessarily know what license it originally was under. Bradley Kuhn of the Software Freedom Conservancy asked GitHub in June of 2021 for legal references to back up the fair use argument. Microsoft was never able to provide any. Mr. Butterick says that's because there is no legal authority for Microsoft's position. And I know Bradley. I worked with him when I was at the GNOME Foundation many years ago, and I don't know if there's anyone smarter when it comes to open source licenses. So if he's concerned and asking those questions, maybe we all should be. But Mr. Butterick goes on and shares a couple of examples. He shares tweets from Stefan Karpinski and Chris Green, who wrote code and then wrote the original code and then shared exactly what GitHub Copilot was suggesting, and it was the same code. Now, when we look at Copilot usage, Mr. Butterick is asking, what could the impact on open source communities be? And I think this is a great question. He argues that Microsoft is creating a new walled garden that might inhibit developers from discovering traditional open source communities. If Copilot is suggesting large blocks of code, why would you ever need to go look at the source code repository or talk to the developers on a mailing list or a forum? The list goes on. So he brings up some good concerns. Now, I used Copilot right up until it became a paid product. As a hobbyist, I wasn't really ready to open my wallet. And even the CircuitPython large parts of that were written using Copilot. And I was able to refactor large parts of it very easily with just a couple button clicks. It's cool, but it's also kind of scary. So this is something I want to keep an eye on, of where it's going and what is that impact on open source communities.
Yeah, I think this is a really great sort of much easier to understand example of the problem of these AI systems. Like there's been some talk of are these AI art generators like DALL-E and stuff getting their data from? because like, oh, this looks a lot like so and so's artwork that's really popular in this community, you know, and I wouldn't know them because I'm not in this community, but anyone who's in that community knows it. That's like, clearly this is informed by it. But it's kind of hard because of the way it kind of mushes together all the different influences. Whereas this, it's so easy to see that like, oh, it's totally pulling this function from this very well-known piece of code. And then it's also copying the wrong license that was at the top of another file that just happened to have a similar. And so it's just like, it's not only is it just kind of stealing code and not attributing it correctly, it's then putting the wrong license on it. It's just like, come on, man.
Right. And if it's GPL licensed, you can't be doing that, period.
Yeah. Yeah. I like how that GitHub is, or whoever it was touting this as a sort of improvement to the IntelliSense sort of code completion stuff. And I've always had a problem with that because me being an old grizzled programmer, you know, I don't want to just be able to like tab through my function definitions and have it autocomplete everything for me. I actually want to like look at the API docs and find out what I need to actually give to the function. And so on the one hand, I'm like, people shouldn't be using this stuff anyway. But the other hand, I also copy stuff from Stack Overflow, you know, and usually I try to give attribution to that because I'm like, thank you, anonymous person.
Well, almost all of my CircuitPython projects are some form of a product that Adafruit did. I take their code, I modify it. I don't think I've written, you know, a code from scratch yet, but I always leave those attribution lines at the top and make it really clear where this is coming from.
Yeah, well, that's the thing, is we're always building on other people's work. Like none of us, like unless you're getting the sand off the beach and making your own chips in a forge, you know, it's like everyone's building on someone else's work.
What's your next one?
All right, so speaking of reusing code, so I'm a newbie to Python, but I've been using CircuitPython for many years. And so I want to talk about a ULab, the NumPy for CircuitPython. And so if you're a Python person, have done any sort of Python work, you probably have come across a NumPy. It stands for like numerical Python. And it is designed for doing operations on large sets of data. And you know, in a lot of programming languages, you've got like say you've got a list of numbers, and you do a bunch of math on those numbers. Like say maybe you just want to add 10 to all the numbers in your big list. You could write a for loop and you just go through each one, add 10, add 10, add 10. And so that's one way to do it. But in Python, if you're doing for loops like that, you're probably doing it the wrong way because Python is not that kind of a language. Like in C, that's the way to do it. So you usually try to use some sort of a built-in function. And so there are built-ins in Python for things like the concepts of map, filter, and reduce, and that can help you. But if you're doing math stuff, you need math type functions. If you've got matrices and vectors, you want to do vector operations, you need NumPy. And NumPy is used for like all this kind of stuff for like editing images, audio, machine learning. It's a efficient wrapper around a bunch of matrix math that's all written in C. It's really efficient. And so you start to think, when you use NumPy, you really start to think of Python more like Lego, where you find the various blocks that are perfect for building your thing. And yeah, you could try to build everything out of one by one Lego block, but it's probably not the right way to do it. It's going to be a lot slower and harder to deal. And so, so CircuitPython doesn't have NumPy, but it does have ULab. It's basically just the array and vector math portions of NumPy. It doesn't have all the linear equation solvers and the curve fit analysis type stuff that NumPy has. And that's perfect because the stuff I want to do in CircuitPython with large arrays is usually like large arrays of LEDs, of neopixels. And one of the common things you want to do when you're doing doing LED animations is fade all the LEDs down a bit by some percentage. And so like if you just were to turn all the LEDs on and then fade, they would just kind of slowly fade to black. And pretty much every LED animation you see will have this at some point in their code. Some examples, like the Cylon effect, where it kind of has the light go back and forth with a trail behind it. Well, the way you do that is you just light up an LED, fade all LEDs by a little bit, go to the next LED, fade all the LEDs a little bit, and you just, from those two steps, you get a natural one light moving with the trail behind it. Another is like a firework effect where it's like psh, 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 and the fades kind of go. All you do is pick a random LED, fade out, pick a random LED, fade them all out. And so that's what this is. But of course, if you're listening to this, you can't see this. This is a fire effect, and it's a pretty reasonable fire effect. It's just a matrix of LEDs, all turning orange, or random one turning orange and then fading down to black, and looks pretty good with the diffusers. It actually is kind of a reasonable, like cheapy fire effect in like 8 lines of CircuitPython. And the way that the reason why this can actually work is because I'm using ULab, or like CircuitPython NumPy. If you were to do the for loop on 256 LEDs, doing a little fade down, it would take 40 milliseconds. And that really impacts your frame rate if you want to do like really cool fast animations. But if you have the same type of fade in ULab, it only takes 4 milliseconds. That's 10 times faster. And so in the show notes, I'm going to have links to a little write-up I have on this, and some links to some videos on some like effects you can do with it. But I'm curious to see how I can expand this. I want to maybe make a little LED sort of toolkit that people can use that's based on ULab math.
Oh, that's great. And I'm not sure if it's ULab or MicroLab, but I use it on all of my audio reactive projects. So right on. It takes the microphone input, converts that to a matrix, and then converts that to the LEDs.
Oh yeah, totally.
There's a FFT equation. Is that the word I'm looking for?
Algorithm.
There's an FFT algorithm that Jeff Epler at Adafruit wrote. So if you're ever looking for audio reactive projects on the Adafruit Learn site, almost all of them use MicroLab and use that same FFT calculation.
Yeah, that's like one of the best things they kept when they were stripping out all the stuff that makes NumPy very huge. One of the best things they kept was the fast FFT algorithm that's in there, so you can do stuff like, I want to show the frequency components of audio, and that's easy to do when you've got this little NumPy thing that just says, take this sample of audio and turn it into an FFT.
My last one is a fun one. This is called MakerDeck. And I would encourage everyone to go to twitch.tv/MakerDeck. And what you'll see is anywhere from 7 to 9 3D printers going at the same time. This is a Twitch live stream, and it technically can be anything maker related, such as crocheting or painting, but I've only seen 3D printers on it. This is a wonderful community. Now, I like watching it because I find 3D printers soothing. I find them almost mesmerizing. And if I'll turn it on an extra TV or put it on my extra monitor at times. And it's fun to see. They have requirements. If you go to that Twitch page, you'll see what you need to do to join. But one of the things you have to do is add your name and then the name of the thing you're printing. So it's sometimes fun to see what other designs people are printing for inspiration as well. But the community is headed up by a gentleman by the name of Chris Perello, and I linked to his Twitch account as well. He goes live every night, I think, around 6 p.m. Pacific. He's a huge Star Wars fan, so he's always printing something Star Wars related. This week it was the pumpkin TIE fighter. Imagine a Star Wars TIE fighter, but the middle is made out of a Halloween pumpkin. He's got a whole crew that helps him out. Zombie Hedgehog, Fix'em Dude, Pezliz are their handles that they go by. There are people that are 24 hours a day managing which printers are on that stream. Everything you'd want to know about it is on the Twitch page, but they have a wonderful and very active Discord community as well. This is somewhere where I've lurked. I think I joined a few months ago, but I haven't been an active member. But it's so fun just to watch all the enthusiasm around 3D printing. If you have a 3D printer if you have a 3D printer, it's a community that you might want to look into. The Discord has channels for everything you can think of, from just chatting in the cantina, again, Star Wars themed, to models to make, to showing them off, or even tech support if you need help. It's just a great community that just has a lot of fun and shares that fun with everyone they can. Highly recommend it.
This is so cool. I'm looking at it right now, and it's a bunch of different kind of 3D printers too. It's like there's some random Delta, there's a Prusa Mini, there's like an Ender, there's like some homemade thing. It's so cool to see. I mean, this person's got 2 3D printers actually going in his little window of the one of 9 that's currently visible. And yeah, and it's so relaxing to watch things slowly create in a 3D printer, and in this you get 9 of it all at once.
Yeah, and to your point, it's cool to see the different printers, and even to see how they're modded. What fans are they using, and get inspiration on how to take my printer to the next level from there.
Totally. All right.
Well, that's all we've got this week. Thanks for listening. For show notes, transcripts, and to support the show, visit thebootloader.net or follow us on Twitter @thebootloader. Until next time, stay positive.
Bye.